Oh, hello there. Welcome to video number 183. This video is on Pythagoras in 3D shapes. So the keywords are Pythagoras, square root and hypotenuse, same as they are in the Pythagoras video. In fact, Pythagoras helps you work out missing lengths in right-angled triangles, and we're going to find those right-angled triangles in these 3D objects. We're going to slice up these 3D shapes and find some right-angled triangles. And square root is how you undo a square number. It's the inverse thing. And the hypotenuse is the longest side of a right-angled triangle. It's the side that we label C. The theorem itself is a squared plus b squared equals c squared. Should know that by now. Now this is some grade 8 stuff, some higher stuff, but it's all right. It's not too bad. Now identify the right-angled triangles in the problem that you need to use Pythagoras on. Use Pythagoras to find one length, and then do it again for the other. It's all about using the formula twice in 3D shapes, or you use the Pythagoras to find a missing length, and then you just use that in the next calculation to find whatever it is that you've been asked to find. And I've put in pink, look out for ratios because it makes things really tricky. Anyway, let's get on with the first question. So the first question we've got shown as a cube. Find the length of AG, give your answer to one decimal place. So AG is here to here. Alright, so we draw a little line that joins those 2 points together. Okay. Now, for us to find that length, we need to find a right-angled triangle, right? Now, this is the right-angled triangle that I'm looking at there, right? We can slice it into that right-angled triangle. And we've got this length here, because this is a cube, so that's 6 centimeters. And that is also 6 centimeters. But we don't have this length here, all right? And we need that length there in order to get this length, A to G, okay? Now, I'm going to draw that out after I've drawn another one out. Okay, and that's this one that's on the base. We can work out this length here, A to C, by using Pythagoras. Like I said, you've got to use Pythagoras twice most of the time. So let's draw that triangle out. Okay, so it's 6, 6. I'm forgetting what the units are for the moment. Doesn't really matter. And then we're going to work out this length here using Pythagoras. Okay, label it C. That can be A, that can be B. So C equals the square root of 6 squared plus 6 squared. Okay, and that is pretty simple stuff, because it's just some grade 4 stuff right there. Okay, so 6 root 2. Keep it as 6 root 2 for the moment, don't matter what it is, because what we're going to do is use that in that calculation there. So we can, instead of having that as labelled as C, we can have it as 6 root 2 now. Okay, that is A to G. We have got that length. Sorry, that is A to C, not G. Okay, that's A to C. Let's get rid of that. Don't want to confuse you. We haven't found A to G yet. I've just messed it all up. There we go. A to C. So if we've got A to C now, we know that's 6 root 2. Could write it on there. We've got this triangle here which we can draw out. So we've got this one. There's our 6 root 2 length, which is A to C. And then we've got C to G, which is 6 centimeters. And there's our right angle, so we're working out the hypotenuse again, the longest side. And yeah, that's just going to be a case of, I mean, you could call it D if you wanted, because A squared plus B squared plus C squared equals D squared in these problems. You could do it like that. That's a quick way of doing it. But let's just call it AG. All right, so AG equals the square root of 6 root 2 squared. Let's pop that in some brackets like that, plus 6 squared. That's what our answer is going to be. So square root of answer squared plus 6 squared equals 6 root 3. So that's 10.39, so 10.4. I'll write it down there. It's 10.39 dot dot dot, and then A to G equals 10.4 centimeters. Okay, and that'll be yeah, a good thing to know, because what they quite often ask in these sorts of problems is, does this stick fit in this box or something like that? And you have to go, well, it won't fit in that way, but the longest length in there would be this diagonal here, from this point here to this point here, or this point here to this point here would be exactly the same length. All right, and then you can see if that stick fits in the box or whatever it is. Probably a snooker cue or something. They love that sort of context in exam questions. Anyway, let's have a look at the second question. Got to calculate the volume of a cone. Answer to 3 significant figures. Now, the volume of a cone, you will be given the formula for that. All right, that's 1/3 of the surrounding prism. So the surrounding prism would be a cylinder, and a cylinder is worked out by doing pi times by the radius squared. So 1/3 times by pi times by radius squared times by the height. Okay, cylinder is pi r squared h. It would just be 1/3 of that. Okay, so there's our formula that we are going to use to work out the volume of the cone. Alright, but what we don't have at the moment is that h. Alright, we don't have the perpendicular height. We've got the slant height. Don't be tempted to use that. That's the wrong height to use. We want the perpendicular height, always perpendicular. So we've got to use a bit of Pythagoras to work that out. Okay, it's Pythagoras in a 3D shape. Yeah. So it's just that 12 squared minus the 3 squared is going to give us h. Let's just write down h equals 12 squared minus 3 squared. The height, the perpendicular height equals, and let's just type it in, moving that out of the way so you can actually see what's going on. So, oh, I had already pressed it, didn't realize I had 12 squared minus the 3 squared. Got to put that bigger number first, otherwise it becomes a negative number, which we don't want. So 3 root 15, let's leave it as that for the moment, and that's in centimeters. Okay, and then we substitute that into that formula. So the volume of the cone equals 1/3 multiplied by pi multiplied by the radius is 3, so 3 squared multiplied by the answer. Alright, and then the volume of the cone equals. Let's find out. So there you go, 109.5. We're around it, 3 significant figures, so 110. That would be 110 centimeters cubed, because it's a volume. We measure volume in cubed units. There you go. That's how you do that one. So we had to use Pythagoras in a 3D shape to get the height, and then once we had that, we could work out the volume. And like I said, that would be given to you in the question, in the exam paper. That formula for the volume of the cone. Now in question 3, we've got a bit of ratio stuff going on here. So shown as a cuboid, we've got to calculate the length of x to y. So obviously we're using some Pythagoras again here. But we've got this ratio going on. Point x lies on AB such that AX to XB is 1 to 2. So A to X, there to there, is one part out of the whole 3 parts all the way along. Okay, and we know that length A to B is 60 centimeters. So it'd be a good idea to split this up already. Okay, so that's going to be 20 centimeters. Because if we divide, it's just sharing into a ratio. 60 divided by 3 and then times by 1, you get 20 centimeters, and that's going to be our 40 centimeters there. Alright, that bit. And then point Y lies on HG such that HY to YG is 3 to 2. So again, this is 60 centimeters because it's a cuboid, right? So 60 centimeters. Maybe I should write down what I'm doing here. Didn't do it for this bit, did I? But let's write it down for the first bit of what I did. So I took the 60 and I divided by 3, and that gave me 20. Did 20 times by 1 and got 20, and 20 times by 2 and got 40. I was just assuming you knew what I was talking about, but I should never assume. Okay, so that's our centimeters and centimeters. Now, same thing again for this one. I'm going to get 60, but I'm going to divide it by 5. The added up ratio there is 5. It's going to give me 12, and I'm going to take the 12 and times by 3 and get 36 centimeters. So H to Y is 36 centimeters. And then 12 multiplied by 2 is 24 centimeters. So Y to G is 24 centimeters, which doesn't look like it is, but it is, right? Because we've done the maths. So there you go. I'm just going to get rid of that because that is the first kind of hurdle over with. And we get marks for doing that, for sure, or a mark at least. And then what we do is we need to think about the right angle triangles we can slice this out into. So I'm looking down here. I'm going, if we directly down there, Y to whatever we want to call this point, and then join it to X here, we've sliced out a right angle triangle. Okay, hopefully you can visualize that and see how I've done that. Okay, and if we've got that there, what we also need is to go line parallel to BC. All right, there to there. All right. We can get another right angle triangle. Now what we don't know, we do know this length here, we know that's 4 centimeters, All right, that's not going to change from BC. But what we can work out here, all right, is what x to this point here is. Okay, and we need that from this ratio, the way that we worked out this ratio. So we know that this is 36 centimeters to y here. So this is 36 centimeters to this point here. We know that there to there is 20 centimeters. So that must be then 16 centimeters. All right, so I'm doing 36 centimeters minus 20 centimeters. That's giving me 16 centimeters for that base of the triangle. Let's draw that triangle out, and let's call that point P and that point Z. Right, doesn't matter what we call them, right? But just for your benefit, there's X, there's P, and there's Z. Right, there's our right angle triangle, and we know that that is the base there of 16 centimeters because we can work out the difference. That's 4 centimeters. Obviously, this is not a scale drawing. Now we can get this length here between X and Z. Right, we need that. We've got that because that's 8, yeah, and then we can work out what that is. So it's just Pythagoras twice again. So let's label this C. C equals, in fact, let's just call it X to Z. XZ. XZ equals square root of 16 squared plus 4 squared. And that equals 4 root 17. Oops. And then we square that, and then the 8 as well. So we've got x to y equals 4 root 17 squared plus 8 squared. Okay, hopefully you can see that in that triangle there, but I'll draw it out for you as well. All right, that's the second right angled triangle. That's our base of 4 root 17. Not sure what that is that an actual number? And that's 8 centimeters. Okay, so we're finding x to y there. That's the length that we wanted at the beginning of the problem. And that's the calculation that's going to do it for us. So let's type that one in. Let's go with the answer squared and then add 8 squared. That gives us 4 root 21, which is 18 point something. Let's round it off to 3 significant figures again. So 18.3. So x to y equals 18.3 centimeters. All right, now I hope all of that makes sense. We've done some really tricky stuff there with Pythagoras in 3D, but it is grade 8. So I hope you enjoyed it. I hope it all makes sense. Please do like, subscribe, share, and practice. Most importantly, that's what it's all about for me. All right, if you guys can use this and practice, and I've helped you somehow without actually being in the same room as you, that's a fantastic thing, isn't it? Nice short video, this one, for this particular topic at the moment. It seems to be taking ages doing these, but yeah, thanks very much. See you in a bit.